Okay. I remembered the size this time, so you can read things. That's always good. Feeling pretty groggy today, pretty tired. Bit of a malaise, so hopefully we can get somewhere and get me excited. So, we left off parsing this call. I think we left off parsing this. Oh, well, I guess I don't have to guess. I left myself a comment, so that's always nice. We are parsing this as a variable decal node that properly has children for its templated parameters, and we've also tagged the node properly to be able to define nodes with which we need to generate structs from. So what we can do now, I think, is let's go to codegen and go to the post pass. So we need to is there something to do in the post pass at all? I think we have everything we need right here. Like, I suppose we could tag this as something else, but we really don't have to. I think we can just, in the metaprogram, look for variable decals that have that flag, and do our thing. Let's just try it. Let's just start at the metaprogram. Let's just start there. So let's go look at generate function templates. Yeah, let's just start there. Let's have a generate struct templates as well. I don't know if we need a first time for them, but structs have them. I mean, functions have them, so we might as well. Is that this very next function? No. Okay. Here's what we'll do. Let's paste this. This will be struct templates. Okay. And what did we do the first time here? Or did we? Okay, we're not even using this first time here, so I'm just gonna get rid of it. That's fine. If we're not using it, we're not using it. So, okay. So, I don't really want to be staring at this function the whole time making this one, because I've had too many cases where I do basically the same thing in two places, and I find instead of just duplicating what this one does over here and doing it for structs, I have found in a lot of cases that I actually do it slightly better a second time, having had the experience, at which point later I can then retrofit the new one backwards, kind of improving the overall code quality. So I think that's what I'm going to try to do here. I'm going to try and just not look at the function one while I do this. So iterate all of our variable decals tagged as struct templates. So for each node of type in tree, we're going to look for all our variable decals. And actually, this is a bit of a weird one. We actually have a few different ways, a few different node types that all share the same underlying, they share the same, what do you want to call it, like class of node, not class in a C++ sense, but you can see here all of these things, a decal variable, a parameter to a function, a member in a struct or union, enum, like any of these are all variables. And at least in the case of these three things, these four things, these are all valid candidates for being template struct instantiations. So I can't just loop over variable decals here. So I suppose we can either pass in this type here and just call this function for every one, or find some way to collapse these down in an user-friendly way and just do it all in this function once. And I'm not sure which I like more. Well, I know which one I like more. I like collapsing this down and not passing extra info here and calling this multiple times. That's just more work. So if we go look at this macro, it's kind of gnarly, but we only compare against one type, and I feel like I don't actually know. Can macros have, obviously they can be ellipsed, right? Like you can pass them a whole let's actually look at this. This is a place I have not really explored. So let's say C++ macros, variable args. I think this is a case where it's all or nothing. Actually, no, that's not true. but it just expands like this. I don't think you can take one individually. Or if you can, it's not something that I have a ton of experience doing, so... yeah, I don't know if you can turn this into a bunch of if statements for each. Yeah, I don't know if I want to do it that way. Regardless. So here's what I can do. We can make a... We already have the struct for like what you get as a result of your query. And right now it takes a bunch of memory, like just in place. And I actually have this giant to do here. I think we can do this same query without... Hey, David, things are... coding goes. I just started. Today's been... I've been a super laze today, so... hoping this picks me up. So anyway, I think I can do this whole query in place without taking any memory. Like I can basically make a... It's just a macro, right? I think I can turn it into a in-place loop, but for now that doesn't matter. But I think what I can do is let's create another struct here called node query input. And here's what I can do. I can say it takes a... Is there no easy way to do this? I mean, I guess if you want to do it this way, you'll just have to set it up manually. So we'll just say it has a types that you're looking for, and let's just say you can only query like 8 at a time. That seems reasonable to me. And should we pass a number of valid ones? What is a 0 one? Did I set myself up for... So unknown, you should never see these, so it's okay if... Actually, can I do like a... Like, will that initialize the entire array to that? I actually don't know. And do we have any of those anywhere, even? We don't use that for anything, do we? Empty compound statement. So we have it in... Okay, that's weird. I don't know why we do that. So I think we can do that. And in fact, just in case, I don't know that I have to do this, but I will. Damn. It looks like fun as someone who doesn't do it, but that also sounds grueling. Okay, so those will all be no ops, and then so we can actually early out once we see a no op, so that's good. But so just give me the types, and we'll do a little trick here and say there will be a constructor for this. The default one that takes nothing. No, there won't be one that takes nothing. This one will take a single type. Types 0 equals type. And then there will be one that takes well, no, we'll just say that. So that means you should be able to still do what I'm doing here and just pass it a single one. Right? No, actually not, because this is a macro, not a function, so never mind. That sounds fun. I definitely want to do that. For sure. Sorry. Okay. I don't actually think I can do this way, because this is a macro, and hi, I was interested to see you call a function from a struct. Can you expand on what you mean by that? See you, David. That was fun. Definitely want to come out and see you again. Yeah, Rugs, if you can tell me what you mean by call a function from a struct. Are you just talking about like member functions and calling them? Sorry, I may just be misunderstanding what you're asking. I don't think I can do this. So let's just do the dumb way for now, just so I can make some progress here. And we will say for each node of type entry to support multiple type queries at once. So this will be for a variable. Let's see what other ones are. Variable, param, struct. Let's just do all these. 1, 2, 3, 4. This is a param. This is a struct member, and this is a union member. So each one of these could theoretically do it. So we will just do all of them. No big deal. Okay, so for each node of type, let's grab a pointer to it. The decal will be there, and we will only, we can skip over any of them if what did I call these? Decal info. Metagen parser decal info variable. We'll just call this the info. Okay. So if this does not contain this flag, it's not the case, that info flags continue. This instantiation. Can't spell today. Skip it. Okay, so if we do this, let's just print out that node. And we should just see we should only see this any struct. Right? This doesn't need a generate function templates. Oh, these don't need this anymore. We're not actually doing that. Okay. Info.flags, that's a pointer. There we go. So the only node that got printed is in fact our struct instantiation right here. So we successfully find them, and the metaprogram knows what they are. So that's great. Okay, so next step. Let's okay, we have decal. Let's figure out how many params this has. Which I said would be based on the template. So, template for the struct. So for each node of type in tree. So here, we're gonna do this. We're gonna say template. And in the AST, we're gonna look for decal structs. And if node info decal struct name equals decal info type, right? Yes. If it equals the type, any struct, then we found the match. So template equals node, and we can break out of the for each. Okay. Ooh, is that gonna break out of both of them though? This might be a problem. Breakout is equal to 1. Right. That's not great. I think this is going to break us out of both. Okay. I'm gonna have to find a way around that. Okay, let's just use a goto here because and unfortunately, 4coder doesn't understand these labels, so this is just gonna look kind of ugly, unfortunately. But let's make sure that that worked. Let's print out the decal and the template. And we segfault. Cool. Why? Wait, we printed this out. And then we segfaulted. Interesting. Does template somehow not exist? Okay, that worked. Weird. I guess we can step through this because I'm confused. We are in how do I get to all of my tabs? How do I see them all? Arg. Okay. Here we are. Let's just go here once we find it, which I expect to find it, which I don't. That's interesting. So. Okay. So why don't we find it? For each node of type. Okay, let's just start stepping through here and see what we find. This node is string builder. Do we eventually find... Oh, duh. We have a new node type for this. Of course we didn't find it. We have a metastruct template. Those are what we want to be looking for. Doi. These are metastruct templates. Now we will definitely find it. I am confident. So let's go back and try this one more time. Yeah, okay, we found it. So, and as you can see, these... Oh, you know what? We already have the pointer to it. We have already hooked those things up. So we actually don't have to find this in the first place. Yeah, okay, that makes more sense now. I wasn't sure what you were asking, Rugs. I see this isn't C. That makes more sense now. Yeah, the metaprogram code and the parser and all that is written in C++. The code that I'm parsing is basically C++, just with some extra syntax that I've added to the parser. So it's basically its like own little mini new language. And really, even the metaprogram is basically just C. The only things I'm using from C++ are some light use of constructors and destructors, and function and operator overloading. Those are two things I use a lot. Well, the operator overloading I use a lot, and the function overloading I use a lot. But some light constructor destructor stuff. So it's basically C with just some C++ stuff on top. Gotcha. Yeah. I don't even really do that, actually, in my code base. Now that I think about it, I don't really use member functions. In fact, I don't think I use them at all. So the closest I do to member functions are in my platform layer. I have function pointers. So like every platform gets one of these platform APIs that exposes things the platform wants to do, like allocating memory. And these are function pointers that then each platform sets, so they're like all in one place. And those aren't even really member functions, they're just function pointers, which exist anyway. So that's like the only place that really shows up in my code base. So okay, well, I know I found this, but do I need to even look this up? Because this type node should be pointing to it already. So I guess what we can do, grab our type node, the template, and search for it if it's not there. So let's do this, info type node, and we'll do this only if we didn't find it earlier. Yeah. So actually, let's print this again just to verify that that works. I know that it will, but let's get this stuff back. Damn it. I just copied again instead of pasting, so that's fine. Let's grab this and go forward in time. Where are we? Here. Let's print those back out. What's metaprogramming? So, it's kind of an involved topic. I can give a really brief overview here, but actually I just uploaded a video last week to my channel. If you look at my most recent video, that kind of goes over the metaprogramming thing, but basically it is, you're writing a program, you're writing code that writes more code. So, if you look here when I build, I just compile some regular code into what I'm calling a metaprogram. The metaprogram runs, and it scans the rest of my actual code base and spits out more code for me. So, for example, all of the code in this file over here, I didn't write any of this. The metaprogram wrote it for me. And so, for example, I have an absolute value function that I don't want to have to write this for every type that I use it on. So any new time I call one with a new type, the metaprogram can see that and generate this for me. That's a really basic example of metaprogramming. If you're interested to see kind of more holistically, definitely take a look at my channel. My most recent video has an overview of the concept. Yeah, and it's super powerful, and I basically have two ways in my system to write the metaprograms. So one way is embedded into the text of the file, so you can see, you can define functions that just take, instead of a certain type, the type is this any. So then it generates the functions based on the call site, based on what you passed it. It'll go generate them for you. That's kind of the quick and dirty way to do it. Well, I say dirty, it's just a quick way to do it for simple functions. But then the actual metaprograms are written in C, and they just look like this. In fact, it's what I'm doing over here right now. You can basically, all these metaprograms get run during this step here, this running metaprogram step. And you can see, you can just like loop over all the structs in my whole code base and do stuff with them, like spit out more code and stuff. So this is kind of what the metaprogram looks like. You can like create function decals and then add them to the program and stuff. And that gets run every time I build and compile. If the metaprogram changed, I recompile it. I always run it, and then we compile your main program. So again, if you're interested, that I have a video that covers that whole process in more detail. So, and right now, the goal is to introduce this any syntax to, will it generate duplicate code? So as long as you go through my API here, so like, where did we go? As long as we go through my API here, this like add function decal, where you set up the decal through my API, this function here will deduplicate it. It won't add multiple declarations of the same thing. It's smart enough not to do that. If you want to bypass this stuff, which you're totally allowed to do, you can kind of just manhandle the syntax tree. You may run into some problems at that point, but there's nothing stopping you from doing that as long as you know what you're doing. And because if you're curious the way this works, I can show you what the tree it's generating. So technically, those metaprograms are operating on this tree of your entire program, broken up by file. So just a quick digression here. If I pipe this out to a file and open it in Emacs. So if I search for AST source file, so here's the root of the tree right here, and then every child of the root is a source file. Every child of the source file is the tree version of your code. So if I go to main here, here's main. Here's main. So here's my main function, right? And here it is in the tree. It's a function called main that returns an int. It has two parameters, and here's the compound statement, which is its body, and then here's all the code, right? So the metaprograms get given this entire tree and can loop over it, insert new nodes, and that's how the modifying of the program happens, is by modifying this tree directly. So that add function decal to program, what this is doing is generating a node that represents your new function and sticks it into the tree. And then later, that tree is then converted into C code. Yes. That tree is the first thing that happens. The parser's job is to go over all of your code and create that tree. And then it hands that tree to all the metaprograms to do with what they wish. And then at the very end, there is some validation on the tree, but at the very end, I then do a dependency map on the tree. So I know what things rely on other things. So then the ultimate C code that gets spit out at the end is actually order independent. So if you see here, I'm using this struct here, but I don't define it till it's down here. That's fine, because like I said, I'm doing a dependency map on the tree. So the resulting code that you write for your program is totally order independent, which is another nice thing about manhandling the tree and the code gen like that. So yeah, hopefully that makes sense. Like I said, I break it down a lot more in that video. Definitely recommend you watch it if you're interested. So yeah, right now my goal right now is to the same way you can do functions with that any type, I want you to be able to also instantiate structs like that. So for example, this struct, you can pass in the type much like a C++ template, and then instantiate them kind of on the fly. I say on the fly, it's still at compile time, but you know what I mean. Okay. The metaprogram, the parser, the metaprogram, the codegen, all that stuff is in C++, or basically C, but it is C++. And then all this stuff is in, I'm just calling them DB files. It doesn't really matter, but this is basically C with my own syntax on top. So, and some stuff stripped out. So the bulk of the stuff you're going to be seeing me write right now is all in C++, because that's where the metaprogram stuff is. So, in fact, I can show you here. DB metagen. This is the parser, metaprograms, and codegen. This is all C++. DBP is going to be my platform layer that I'm building in this mini new language. So these are all the DB files, except for the metaprogram stuff, which again, you write the metaprograms in C. So that's kind of how the files break down. Okay, I think we found this, so I don't think there's anything else to do there. That just worked. Yeah, we still found it. So we don't actually have to loop if we don't want to, or if we don't need to, so that's good. We can just find it directly off the node. So now that we found it, we have the decal and the template. Let's print out the decal to see what we have to do to it. No, we need to generate the thing first. So, don't bother generating anything if this already exists. So, do we have a struct exists function? Exists. We do have a struct exists, but that requires you to build it first. So let's create a utility that gets us the struct name from a template. No, the struct name from a call site and a template. Struct name from call and template. Let's just be super verbose, because I like to be verbose with my names. So let's pass it the this is going to be the decal call site and the template. So we want to let's do this first. Let's get generated name is struct name from the decal template. Let's just print this out for now. So do we see test? We do, cool. What we really want is the name of the template to start. So template info decal struct dot name. Great, any struct. So for every type we pass to it, I think we want to say, so let's do this. In this case, the resulting struct should be this. That's what it should generate. So I think I can just loop over all the template parameters. And if it's a type I have to get from the call site, I'll grab it. If it's not, I skip it. I think that'll just work. So let's, here we are. Let's just, for each child node in the template. Okay, if is type any, or is type any of, or is type, no, what did I say, is, what did I call that? Because type is stupid. Is type arg, which is, that's probably also a weird name, but it's fine. So if it's any of these, need the type from the call site. Otherwise, it doesn't need to be part of our name. Or does it? Actually, it probably does. Yeah, it does, because can I think of a scenario where those would overlap? Like, if you pass it a U32, nothing at another type. Actually, I don't think it does. So, corresponding call site type should be the decal call site children child index, because they should map 1 to 1. This needs to be get param type of that. I think that's all I have to do. Get param type is a short string. I think that's all I have to do. So result plus equals underscore call site type. Does that just work? Is that going to work that easily? So instead of any struct here, we should see any struct underscore U32. Oh, this is looking at tokens. Right. Decalvar, here we go. Decalvar is type. Again, it's goofy, but so instead of is type any of, and is type, we'll replace this is type with decalvar is type. There we go. uint32t. Oh, does get param type follow? It must be following type defs then. Get param type. Okay, yeah, we pass right through type defs, I guess. Is that fine? I guess. Yeah, I guess that'll just handle that for us on the back end. That probably is fine. That's probably fine. I'll call that fine for these purposes. If that causes a problem, we can figure it out. But I'll put a to-do here. Get param type bypasses type defs. Is that fine here? Okay, well that worked though. So we generated a struct. So what if I pass this? Let's have another one where the value is a short string. So there we go. We're generating a bunch of these. We'll make another one, any struct 2, that takes a type, it takes a size, and it takes an any value. Actually, we'll do this because I don't have that wired up yet. But if it takes 3 of these, does that still compile, first of all? Yes. So any struct 2, it takes a, let's give it a F64, let's give it 32, let's give it, oh. We actually do care if you're passing it. In this case, that 32 needs to be part of our name. That will be a unique identifier, which means that's fine for numbers. That's not a huge deal. But if you're passing like strings in, which I don't think you would anyway, but if you did, we don't want to append whole strings to this thing. That is tricky. Because right now, if I pass in like this should work. We should see one with F64 short string. Or double, in this case, double short string, because that's an overload, or a type def. This is now no longer indistinguishable from this, even though we're generating 2 structs from this. So like I said, numbers are easy. Other things, not so much. That is... because that could be arbitrary. You can have a struct that you want to instantiate with any type. That is a much harder problem. Because, like, well, does it make sense to pass anything but, like, would you ever, could you do anything with that? I don't think so. I feel like you would only ever pass non-generics to this in the case of a size for like an array. I feel like we should just limit it to that. I'm calling it for now. I'm going to call that we're limiting it to that. So this is going to be, and in fact, I won't even do floats. I'm going to limit this to integer types. So otherwise, it must be an integer type. To do, I don't see a need for anything else. Okay, so if it's not one of those things, then else this will be okay. So we're gonna say else if, and do I have like an is number or something? Number type matches number type matches integer type is what I want. Oh, but that takes a type string. Okay, first of all, this won't be child nodes because I don't care about the body here. I care about, in the template, I only care about parameters to it. So these can all be node. Then, so otherwise, we just have to say matches number type or integer type, node info decal variable dot type. Yeah. So in that case, call site value. Instead of the type here, oh, we want the value. Which we have to know at compile time. That has to be something we know at compile time. That can't be dynamic. So we'll come back to that. Let's error out here first. So let's not do this first. So let's error out here. Let's say report error and exit. And we're going to pass it the node. No, we're going to pass it the template. I want to say parameters to struct templates can only be generic or integer. Be a generic or an integer. So call site type, this is value. This needs to be a pointer. Okay, so that worked. And if I try to make this like a short string, this should be an error. Reported by the metaprogram. I misspelled parameters. Parameters to struct templates can only be a generic or an integer. DB line 73. Okay, what if I do this? That's gonna be wrong, isn't it? 73. Let's not pass the template, let's pass the node itself. 74, okay. That's just a little more accurate line number, yes. Okay. That's feeling good. Having proper errors is always good. So so here we need to get the call site. I feel like I need to also just limit here to you have to pass me in a literal for now. Well, really, it has to be something I can resolve statically. is the point. And currently I don't have a good way, I don't think, to... This is the same problem I'm running into with parsing format strings down through multiple functions. I need a mechanism to a better way to phrase this. I need a way to determine if I can, if something is if something's value is resolvable, is statically resolvable. This is also going to be an issue with struct templates passing in an integer. They must be statically resolved. Okay. So let's just assume right now that you're passing me a literal integer. Like it has to be a literal that you're passing me, because I don't have another mechanism right now. So let's say eventually we can expand this to any number we can resolve statically. Resolve the value of C to do in main. Okay, so we're gonna say if this is the call site, this is this, so call param is that, call param type. So what are my literal types here? We've got, so this has to be a integer. Like that's really all I'm going to accept here is an integer. AST literal integer. And actually, let's just early out. I don't like having, we're getting a little nested here for how simple this is. So if it's not an integer, for now, you can only pass literal integer literals to non-generic struct template parameter. Okay. Okay, so now it's easy. Now we can just get the literal info. We can just get the integer and toString it. How do I know if it's signed or unsigned though? Do I store that somewhere? It's a lexer token type. Yes, so the literal is on the type. So and wait, why did I care about that? Oh, because I want to grab, okay. So although does it matter? Yeah, I guess it matters. So call site value equals, we will say and actually, yeah, let's just do this. We're gonna grab the literal info. So we're gonna grab call param info dot literal. So we're gonna look at the type. Does the type equal token literal integer? Then this is gonna be toString Otherwise it will be something else. ToString. This is gross, but you know what? Sue me. The text is also quite big, so okay. Yeah. Is that fine? I don't know if that's fine. So we expect this to look like f64 underscore 32 underscore short string. This should be f64 underscore 64 underscore short string. This is not toString. This is int toString. I'm missing something. Can I not have those? Oh boy, this is even grosser than I thought. We're just gonna do that. Parameters to structums can only be generic or an integer. Are they not? Parameters to struct templates can only... Wait. Oh. Let's change this back. There we go. Okay. So that worked. We are generating those properly. Is there a limit to the size that a name can be in C? CPP struct name length limit. Is there a limit? Okay, we're probably fine. I don't think we're going to be anywhere near hitting that, so... And if you are, you probably have other... other things you probably want to do about your code. That is fine, I think. So, cool. We have the... struct name from the template and the call site. So now when we look at struct already exists, are we just looking by name? We are. So how about we have another one of these, and this just does this. We just call through to struct, return struct exists, passing it the name. A point, yeah, let's not do a pointer, it's fine. Struct exists, struct name, and this is struct name. So this, if struct exists, we can just stop. Continue. If this already exists, then skip it. Let's still print out what we were doing before, just to verify that we do in fact skip. Oh, well no, we're not generating anything yet, so let's just assume this works, shall we? Okay. Great. Getting there. Okay. So. Cool. Now we have to do the actual generating. And that is going to be using, we have a utility for this called ast struct decal. generated struct equals add struct create struct decal. Yes. Okay. And this is going to be the generated name. Does that take a pointer? It does not. All right. And let's just break there and just verify that that part works. So let's break out here. And this generated struct should have any struct uint32t. The next one should have any struct short string, any struct 2 double 32 short string, double 64 short string. Fantastic. So let's begin the body. Do I do this anywhere else right now? Type info. Is it just immediately beginning the body? Yes. Cool. These are actually a lot easier than functions, which is nice. So let's begin body of the generated struct. And end the body. Okay. Now, the members. The members are going to be, here's where the meat of the work has to happen. We basically need to copy at each member as we see it. The thing is, if the type of this member equals the name of any of our type parameters we passed in, we have to replace that. If the actually, I'm trying to think, do we even need to support this at all? Does it even make sense to pass an any into a struct? I'm gonna ignore this for now. I don't actually think that's the case. I don't think we have to support that. I don't think that even makes any sense. Because in what situation are you passing a whole ass thing? There's really only two things you want when creating a struct, is a dynamic type name or a dynamic size for data structures, I think. So I think that's true. Also, we should probably, before I move on, I'm just gonna put a to do here and say, wait, what do I do? Because right now, if I did this, I think this would work. Well, let's see what happens. Yeah, that should not work. That should be a metaprogram error. Update struct templates. I need something in here that I need to check to see if that doesn't already exist. So okay, that's actually easy. So we can say Or maybe that's fine, honestly. Does that just work, actually? If we did have these two, I feel like that would work because we're generating the name anyway, but that's confusing. We're just not going to do that. So for each, let's call this for each child node, no, for each node of type in the AST, this is nested in a way I don't like, but it's fine. It's really not fine, but well, it's not that bad because we're actually looking for these, so it's not that bad because there aren't going to be, no, it's still pretty bad, but if node info decal struct name equals struct decal struct dot name. We're gonna report error and exit. Struct template already exists. And we will pass it node source location info for node. Yeah, node. And struct. Decal, this is an info. This is also an info. So, reported by the metaprogram at 75. Hey, this already exists at line 71. So at 75 here. Hey, this already exists here at 71. Great. Cool. All right, that's all I wanted to do there. Just error checking, error messages. They're always good. Especially if they're easy like that to throw in. Those could really bite you later if you don't take care of those. Because then you could come back here later when you hit a weird bug and be like, oh, I really should have had an error here. And now that you're far enough removed from this code, you're like, I don't remember how this code works exactly. So how do I insert a good error here? So I try to take those as we go. So begin the body. So for each, we'll just do child. For each child node in the template, let's just print the node child true. So let's do this. Let's print the template. Okay. Print a new line. And we will tab it out and print all the children. So, any struct. We want to generate a struct, type T and value, right? Wait. The template should only have one child. Oh, no. Oh. No, I want the members. Oh, its last child will be its body. Its last child will be its body. So for each child node of template we'll just say template body will be here's this metagen parser node template body will be, oh, actually we don't need this till down here, so let's do this here. Template children get num valid children of template -1. So the very last child will be the template body, so we're going to loop over all of its... That didn't work. Let's print the template really quick, just to verify that I'm not going crazy. Here's the template. Oh, never mind. Shoot. It's not a compound statement sitting here. It just has children. Okay. So let's not do it that way. Nope. For each child node of the template, if child type is a parameter, we just skip it. Right. And I think we can't just use struct member, because it could be a function, a constructor, or a destructor, right? We can't just assume that it's just a member, so we have to loop over all the children. There we go. Okay. So we match any struct. It's got a value whose type is T. So let's make this other one different just so we can see it. Let's say it also has a short string in it. String. Let's say value is actually an array of size. So, so any struct has a value of type T. Any struct value of type T. Any struct 2 has a value of type T array at size, and a string which is a short string. So we're finding them. So let's actually call this right, so in this case, let's also print out, this needs to turn into this needs to turn into the corresponding call param. Right? So we're going to say call the decal, no, yes, the decal children. Will it be the same child ID? No, I have to find it. I can't just do that. I have to find it. That needs to be found. Oh boy. This is the fun part. So let's hold off on this and So this needs to map. I need to figure out what did we pass in as t. So I need, okay, first thing I need to do, looking at this, which parameter does that correspond to? I need that first. Then I need to translate that param index to the corresponding one here. So I might already have, because I do that for function templates, matching param ID. But that takes a function decal. Matching function decal. Let's replace that because matching param ID. Okay. So here's what we're gonna do. I want a function that gives me the ID, the param ID that corresponds to this. Wait a minute. Is that not what this is? What is this pointing to? Let's take a look what that's pointing to. Let's go look at the tree and see what that's pointing to. So this oh, no, that's just its pointer. I'm misreading this. Oh no, that's its pointer. So what is this? Oh, okay. Its type T is coming from here. That's this. This is the pointer for the actual member. That's confusing. So values pointer is this. T is pointing back to this, which we're getting from the parameter. So does that mean so do I don't actually have to search for the match. I have it directly, I think. I don't have to search for that, I think. Yeah, instead of searching for this, I can just go straight to it. And then I need to get the index from there, which I may have a function for. How? Get child index? Cool. I have that already. All right, this is actually less. I've already got the stuff here that I need for this. So, so if the type of this member is a generic type, okay. But we have to do this for different member types. So I'm going to switch on the type of this child. That's what we're going to do. We're going to say case. we're going to say our possible types are these. Let's do this. Boom, boom. Wait a minute. That's not right. I'm gonna copy and paste this first. You know what? Let's just type it. Let's not rely on the copy paste. Okay, and then our default case. No op. Shouldn't hit. Okay. So, to do. Okay. If it's a member, we want to check if its type is child info decal variable dot type. If type equals type, we do one thing, else wait, I want to see if we're disbarring. So actually, I think in these cases, let's actually error here. Report error and exit. Generic or wait, report. Wait, where am I doing that at? Hello? Am I, what am I? Oh, they're here. We're gonna say parameters, struct template parameters, we'll say generic. Struct template parameters can only be of type got any of. Okay, that's fine. Let's verify that that works really quick. So if I pass an any to this, yep, and if I pass an any of, that's not how that works. This is okay. So that works. Let's go back to what we were doing. So, if it's a type, we need if it's not a type, then we can just add member to our generated struct. The type will be child info decal variable dot type, and the name will be dot name. And then here we need, no, what am I doing? There. We need the type from the call site. So how are we doing that for functions? No, we already know what we need to do here. We need to get the, so S32 corresponding index equals get child index of wait a minute. Oh, of child info decal variable type node. We need it of whichever our type is. We'll call this param index is that, and no, that's not how that works. Yeah, so the type node, its parent should be the that is right, actually. I think that's right. So we have the param index. In this case, we would get back a 1 or a 0 in this case, which means it's the 0th. Yeah. So let's do this. I think we can just do this. The name is the same, but the type is going to be get param type. Do I have a get child? Get child index. It will be decal children param index. I think this is, I don't feel great about this, I admit, but we didn't crash or anything. Let's just look at the, let's look, see what we get. When we go here, let's see what we got. So the first one, we expect any struct that has one member, which is a U32 called value. That's what we expect. So generated struct, this is a good sign so far. Num members is 1. It's a uint32. Let's see what its members are. That's not a good sign. That's a T. The name is right, but that value is wrong. So why is the value wrong? Let's step through this. So if we see a type, what? Oh, our type isn't. I don't think our type is that. I think our type is without the Wait a minute. Oh. That's the wrong... I'm not looking at the right thing. That's our type. That's our type of the very... That's this thing's type. This is the T. I want its type node. Ah, don't do that. Okay, hold on. This needs to be type node. But I don't know that that's a decal variable, do I? Yeah, I can't actually do that. Do I have like a get type name from? I do. Look at that. Although is that even correct? Let's just see what happens. Get type name from. I don't think that's right. I don't think that's gonna, yeah, now we just kind of freeze. Did I close that? No, it's right here. I'm freezing on this actually, so let's come back to this. Let's come back to that. Okay. Type of the first one. Okay, that worked. Now we're seeing type. But that shouldn't be type, that should be star type, or pound sign type. Is type arg. If is type arg, then type equals get token text. Okay. Let's move all of this down here and say if it's an any, let's append this onto it. Actually, for any of these, right? What do I want to duplicate? Do I want to duplicate the ifs or do I want to duplicate the assignment? I think I want to duplicate the ifs. Well, it'll be a single if, but okay. So if it's any of these, we are going to append this with a asterisk or a pound sign. Okay, so now when we break here, we should see a star or a pound type. We do. So if the type is type, our param index should be 0 in this case, which it is. Which means to the struct decal we're adding a type uint32t and we're adding the name as value. That actually worked. That actually worked. So let's get down here. We have one member whose type is short string named value, because this is the second one. That just worked. This one though seems like we froze, so let's figure out why. Let's recompile. Here we're freezing, so, and then actually crashing, so let's figure out why that happens. Get type name from null. We're passing it null. So, oh, we don't, in cases where we don't have a type node. Because, why would we not have a type node? Because this child, struct member, type node is null. Why does that not have a type node? This has a type node, which is T. It's pointing back to here. Why doesn't this? That should be the same thing. Oh. Get type name from. Okay. So when we go in here, we should be seeing a, we just grab the type from no. Okay, why don't we have a type node there? That's not right. So type node equals, where do we do that? It's in the post pass. Find type name, type match for name upward. Not there. Here. Decal type source. It's right here. Here's where we're setting that. What is the line number on the one we're not finding? It's this one. Child. Info. Yeah, so this one we're not finding. The type node. And this child is on line 76. So a struct member on line 76, we need to look at that. What line is this? 419. Right here. Child line number 76. Is this the right one? Decal param. No. 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 Yes. Okay. Find type match for name upwards on this. This should be an easy resolve because it's literally right here. Like it's right here. This should be the easiest resolve in the world. So why are we not finding it? Let's look at our parent, and our parent is wait, why is the parent the source file? This child is a struct member whose parent is the struct. Oh, but I'm starting at the child's parent. Hold on. Source node. Okay, so I'm skipping a step first of all. That's weird. I should not be skipping a step. That That's weird. We should still find it, but we shouldn't be having to skip a step like that. So let's do that again. Nope, this moved now. Damn it. Boom, 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 boom. Okay, so here, if the parent's line number is 75, which it is, it's the struct, and the struct is any struct 2. While we have a parent, let's search that for this. Node match for string. Okay. Inside of for each child. Okay, we're checking child by child. We should match on this first child, actually. This first child is the decl that is a name is T, and we're looking for T of size. This is not matching. This is a T of size. This should be matching to this, because this is thinking we're looking for an exact match by name. This function is for matching names, not types, I think. Node match for string. Yeah, this is for matching names, not types. So that ain't gonna work. We need this to match just the type name. Do I really not do that anywhere else? For name string, decl name string, find type match for name upward, decl type node. Although that is what we're doing, we're just passing it the type. Node match for string. We are using this for types, so why? I'm confused. Maybe it's because in the case of a struct, the name is the type. Find type match for name. Find type match for name upward. Yeah. Yes, we're doing that when we're looking for this is confusing. Bare type string. Okay, so in this case, all right, I think what I'm confused about here is why this same function, decal name string, is getting used for both types and names. That's confusing me. But I think it's because when we go to connect our types, we want to find a type match for our type. So in this case, our type is a, let's say, short string. Well, no, it'll already have it by that point. Type node should already be set in that case, because it or should it? Let's just step through that, because I'm confused. And I'm not going to get anywhere being confused just trying to stare at this. So, right here, we'll say line 77, and the parent's line is 75. So we'll say 77, and AST child parent line number is 75. So this should be here. So how do we resolve this? Right? Type match for name upward. The source node is this struct member who has a type short string but no type node. So we want to find it. So we're looking for short string. Going to look at its parent first, which its parent is this decal struct who has 2 parameters. So these are really what we're going to be looking at first, are the parameters. So let's search that. So this first child we check is this first parameter, which is a type. The decal variable's name. Because it's a parameter. But we're looking for the name short string. I don't know how we're ever finding this, actually. I'm confused. So we don't find it there. The next one should be our short string called... Wait. Oh, no, wait. Okay. We're not matching the name here. We are matching the type. So we want to find where this type lives. We're not going to find it here. We're going to find it here. Where it does... that's what we're looking for. That's what I was confused about. So we are looking for this. We're looking for short string. And we find it here. That's the rub here. So in this case, we're looking for T, which is... Okay, this is just a special case where we're going to have to look... Okay. This is confusing, but we'll get there. So, if it doesn't have a type node, although it should find it. That's the part I'm confused about. Because in this case, this is looking for short string. In this case, it's looking... Oh, it's looking for a type called T. It's because my types... It's not aware of this at all. So... Okay. when I find type match for name, it should do a check here. So, okay, search AST for name string. If it sees a parameter, right? If node type equals AST decal param. So if this is a parameter and this is not type, this is info decal variable dot type. No, this is type, but this is if the type here is this, then we want to return this. Although, wait a minute. The other one is working. The other one is working. I want to step through this other one and see what's happening. We're 72 and 71. Because this other one totally works. So 72 and 71. Value t. Okay. It doesn't have a type node. Wait a minute. What? What? Do I need to recompile? Did I make some changes here? Yeah, I know you break. It's fine. Okay. Child. Info. Value t. Find type name for match. Or type match for name. The parent is the struct. Search the struct for each child. This child is a parameter. Who? This type is type. Does it match? We're looking for T. Okay. This is matching by coincidence. Technically, this case, where this matches to this, is a total coincidence and is not robustly matching on this type parameter. It's a coincidence. And the reason this one isn't is because this thing's type is really a T array of size. We don't want to rely on a coincidence for this. So this whole... this does need to happen here. So if it's a param and its type is type, let's do this now and break there. So instead of going here, even this first case should stop here, actually. So we're looking for T. This parameter is called T, but before we even look at the name, we need to see if this is a type parameter. Because presumably, this would work if this was also like a short string. It would still match the name, which is bad. So we should be stopping here. This should be true. Which it is. Okay. So that's good. If it's a type, then if the name matches So this is still tricky because I don't like how ambiguous this is, that this can be for names or types. Because how do I differentiate these two cases? So in this case, the query needs to change to be substring ss from string 0 to char index from left string. So we want to strip out the array stuff from it. Yeah, this is weird. Oh, that's not returning the whole thing. So the index is that. If... Okay, so this is index greater than or equal to 0. Or greater than 0, rather. Then it'll be this. Otherwise, it will be string length. No, it'll just be the string. Alright, this is getting a little hairy. I don't like what's going on here, but that is a much bigger refactor than I'm planning on doing right now, so... Okay, so we're looking for T. Wait, we're still finding that, aren't we? Yes, I want the next case, so I want 77 and 76. Which we don't even hit, because that's 75, not 76. Okay. So we should be looking for this is not the right one. What? Now we're not even hitting that at all. Oh, is it because... What? How are we not hitting that at all now? Oh, we are. I'm looking at the wrong one. 76 and 75. That was for when I was doing the short string. Dude, I am losing it. There we go. T size value. Okay. So the node we're looking for, or we're looking at, is type name of t, and the string to compare is string is t size. So we're in this case. But now instead of t size, we should just be looking for t. That should be -1. And we find it now. Okay. All of that to get us to match, and it's a little gross, but we match. So I want to put a to-do in here. This is gross. Need to have separate functions for when we're looking for a name match versus a type match. Right now, both places piggyback off of this function. What do I mean by both places? Both places node match for string. Type matching and decal name string. Both query types piggyback off of this function. And it's confusing. And error prone. So let's go all the way back to what we were doing and hit this. So the first struct that we generate is any struct uint32t. It's got one member, which is a uint32t called value. That's this guy, generated from this guy. The next one, same thing, but it's got a short string in it. It's called any struct short string. That's this guy. The next one is called any struct2 underscore double underscore 32. That's this guy. That should be an error because that should not be passed in. Verify number of params. But for now, that's fine. Let's get rid of that. Yeah, that's fine. This should fail parameter validation, keeping it around to test until we do that. Okay. So we are at generated struct. Any struct2 double 32. A double and a 32. Because this is because we passed it to 32 for the size. It's two members, that's good. Its members are a double called value. A double called value. Oh, but it's gotta be an array. this type should be double array of size, or array of 32. So we gotta still do that. And this is a short string called string. Yes. So getting there. We are getting there. So we need to get a type from the call site. So this. We have the type from the call site. We need to reconstruct the proper type here. For example, we successfully match T to the one passed in, but our resulting, for example, U32, but then our resulting type needs to be U32 size, not just U32. We also, at this step, need to replace size with the actual value if it was passed into us, aka is one of our params. Okay, so let's explain that. To do above comment. I knew this would be a tricky thing, and it is, but we are getting there, slowly but surely. We are very close to being able to generate these. In fact, this one I think we can generate right now. Anything with more complicated types we can't yet, but slowly but surely. I think I'm gonna call it for tonight. Been very groggy today actually. 9:30. So I'm very happy with the progress here. So this has set up some good scaffolding. I mean, it's more than scaffolding. It's set up a good base for knocking this out and finishing it next time. So I'm excited about that. My brain, I think, has given up though. So left off here, above comment. Also check the other to-dos we generated from this session. They are kind of all over the place. Okay. Cool. Well, thanks for watching. I'm gonna go ahead and push this up. Little bit of a boring stream this time. There was not too much. There was progress, but not a lot of visual progress, I guess. Marching towards functional struct templates. Thank you. We'll say more progress on struct templates. Still not working, but getting close. many to-dos. Okay. Yeah, like I said, thanks for watching. I will be back sometime. Probably not tomorrow, but man, I'm getting so close. I don't like some of the code that got generated today. There's some places that feel pretty gross. Most of it was confined to this function actually, so I'm okay, but there's some places like here, this is pretty gross. I don't like it. And if we search for to do, well, actually, there really wasn't that much. It was it's just stuff that I didn't fully think through. So, like stuff like this isn't great. Stuff like I don't know. Maybe it's not as bad as I'm thinking it is. It really is just, I think, this function's single job being split among so many things. Doing this has exposed that in a way that feels really gross to me. So that definitely needs to get refactored and fixed. But at least I know exactly what needs to be fixed about it. Are you able to do like a... I actually don't know. Yeah, can I do a specific commit? I want to see the... I want this. Is that all I need? I actually don't know how to do that. Oh. Yeah, that's what I wanted. Duh. Okay, let's output this to a file. And so, that's not even highlighted. I thought... Doesn't Emacs know about diffs? Does it have to know it's a .diff? I know it does, actually. Okay, it just wasn't a .diff. Whoa, okay, that's a little gross, but... Okay, so what changed here? This is definitely gross. I don't like that. That's fine. That's fine. I just want to sanity check that this is really not as gross as I thought it was. Struct exists. Okay, it's really not. It's just that it just feels really gross because of that one place. So I'm okay with that. It's just this. This feels gross to me. So all right, cool. I will call it a night. Thanks for watching, everybody. Anyone who's still here. I will be streaming again soon, and hopefully by the end of the next session, we will have working struct templates. That is my goal, God damn it. All right, cool. Take it easy. See you soon.